So last class we learned about factoring GCF, and factoring is basically just like taking or it's doing the distributive method but backwards. So like if I were to distribute, let's say I have 2x times x plus 6, and I told you to distribute. I think everybody would know, okay, well, I have to multiply 2 times x, that would be 2x squared, and then 2x times x would be 2x squared, and 2x times 6 would be 12x. So we just pretty much got done doing that because we were just multiplying binomials. We just did that on even a larger scale than that example, or a harder scale than that example. And now what we're doing in factoring something out is we're basically just undoing that. So instead of multiplying something in, we're dividing it out. So if I were to give you this problem, 2x squared plus 12, and I were to tell you to factor out the greatest common factor, that would be asking you to pull out what's the biggest term or monomial that I can divide evenly into both terms, or that is a factor of both of those terms, 2x squared plus 12x. So first you can look at the numbers, so just the 2 and the 12, and you have to think, what's the biggest number that divides into both of them, or what's the biggest number that if I divide it, it'll come out with something even. Well, the biggest number that I can divide 2 by is 2, because anything larger than itself, I'm going to end up with a fraction. So I can divide 2 by 2. I can also divide 12 by 2, so that would be my largest common factor. Sometimes the largest or the greatest common factor of the numbers won't quite be just the smaller number. So remember that you can always make a list. Like if I were to make a list of the factors for 2, it'd be 1 and 2, and then for 12, it would be 1 and 12, 2 and 6, and then 3 and 4. And you can see the largest common one, or the greatest common one, is 2. And then when it comes to the variables, so we have an x squared and an x. And x squared, we know that that just means that's x times x. So if you'll notice, there's two factors of x squared. One is an x and one is an x. So this x is automatically a factor of it. So that means that I can only take the best way to I guess for me to phrase it, or the best way for you to think of it, is when it comes to variables, you can only pull out the lowest amount that you see, because that lower power is automatically going to be a factor of the higher power. So the lowest power that I have across both terms is x to the first power. So I can pull out an x to the first power. And then when I pull that out, I'm just trying to figure out, well, what has to stay inside the parentheses? What's left over after I pull out that 2x? So you can think 2x times what is going to get me back to this 2x squared? Well, I would have to do 2x times one more x to get me back to 2x squared. And then 2x times what is going to get me to this 12x? It would be 2x times 6, so plus 6. And if you check, we kind of got back to what our original problem was. So you can see that you really are just going full circle. So distributing is multiplying something in, factoring is pulling something out. So up at the top where it says factor polynomials 4 terms, these are just kind of steps that can guide you through these problems. So number 1, group the terms into pairs. That literally means kind of pair them together, 2 and 2. And then number 2, factor the GCF out of each pair of the terms. And then number 3, look for and factor out the common binomial factor. So if we look at example 1, where it says factor by grouping, the first one is x cubed plus 3x squared plus 2x plus 6. So I'll give you guys a second to write it down, and then we'll go through that one together. So for A, x cubed plus 3x squared plus 2x plus 6. Number 1, or the first step listed above, was to group the terms into pairs. So that's what we're going to do. We're going to kind of just we don't really have to separate them or anything, or we don't have to put parentheses around them. We can just kind of put a break in between them to show us that what we're grouping together. So I'm just going to separate the first 2 terms from the third and fourth terms, and those will be my 2 pairs. And then from there, I'm going to look at each half separately. So for my first half, for x cubed plus 3x squared, we're going to pretend that's its own problem, and we want to factor out GCF out of just that part. So for the x cubed plus 3x squared, I have to think, what's the greatest common factor that I could pull out of just those 2? Well, the coefficient of x cubed is 1. So my GCF, the number would just be 1. And so if I just factor out a GCF of 1, you don't have to write anything. But I can factor out a variable, and I can pull out the lowest power of x between those two terms, which that would be x squared. So that means that my GCF is either x squared, or if I want to write 1x squared, I can. But either way, it has a value of x squared. And then when I pull that out, I can think x squared times what is going to get me back to x to the third power. Well, I would have to multiply it by 1 more x. And then x squared times what is going to get me back to that 3x squared. Well, I would just have to multiply x squared by 3 to get back to 3x squared. And then we're done with the first half, and now we can focus on the second half. So for the second half, it's 2x plus 6. So I want to figure out what's my greatest common factor of 2x plus 6, and then pull that out in front. So between 2x and 6, for the number GCF, it'd be 2. So I can for sure factor out a 2. I'm going to write that as plus 2 since I'm factoring out a positive 2. And then for what stays inside my parentheses, I have to think what's left over after I pull that 2 out. So 2 times what is going to get me back to 2x? Well, I would have to do 2 times x. And then 2 times what is going to get me back to 6? We'll have to do 2 times 3. So that would be x plus 3 inside the parentheses. So at first, you kind of just treat it like it's 2 separate problems that you're factoring the GCF out of each. And then for the third step, it says look for and factor out the common binomial factor. So you'll notice that each of these terms now has a common binomial factor. So they each have x plus 3 and x plus 3. So we found it, we looked for it, we found it, and now we can factor that part out. So think of it as I'm taking that x plus 3 factor, and I'm pulling it out of each term. And by term, I mean this is one term, and this is another term. So if I take that x plus 3 and I pull it out in front, I've factored it out of both terms. If I pull it out of the first term, I'm left with x squared. And if I factor out of the second term, I'm left with 2. So by pulling it out of both terms, I'm left over with that x squared plus 2. So altogether, this is x plus 3 times x squared plus 2, and then you're done. So just to kind of recap and go back through the steps, we first grouped them into pairs. That's what we did at first, was just separating the expression into halves. And then the second part, or second step, factor the GCF out of each pair of terms. That's what we did in this second row right here. We factored out the GCF of x squared from the first pair, or the first pair of terms, and then we factored out the 2 from the second pair of terms. And then for step 3, we looked for and we factored out the common binomial factor, which was that x plus 3. So we're going to do the same thing with b. So x squared plus y plus x plus xy. We'll give you guys a chance to write it down, and then we'll go through it together. So for b, as it's written right now, x squared plus y plus xy. If we were to break this down the middle, I don't really want you to write this part yet. So don't write down what I'm about to write down. I'm just going to kind of show you. If we were to break this down the middle, the first half, like the first x squared and y, that first pair, it doesn't really have a greatest common factor other than 1. So I won't really be able to pull much out. Sometimes it's okay for there to be a greatest common factor or just of 1, depending on the problem. But we kind of want to rearrange this to at least put the terms together so that they have some things in common once we do group them into pairs. So it might be smart to kind of maybe move this y over with the xy. So what I'm going to do is I'm going to rearrange it and rewrite it as x squared, and then plus x, and then plus y, and then plus xy. So the reason I'm doing that is because I kind of want like the terms that have the y's to at least be together so that that y becomes the greatest common factor. Whereas if it's ordered right now, we wouldn't really be able to factor much out, and we wouldn't end up with a common factor for step 3 either. Okay, so all we did was rearrange it so far, and then now we're ready to group it into pairs. So our first pair, x squared plus x, the second pair, y plus xy, and then now we're ready for step 2, which is factor out the GCF from each pair. So for the first pair, so it's x squared plus x. So my GCF there, they both have a coefficient of 1. So the number I could factor out would just be 1, but I never have to write that. But I can factor out at least an x to the first power out of both because they have at least x to the first power. So I'm going to factor out an x to the first power, and then I can think x times what is going to get me back to x squared. Well, I'd have to multiply in another x, and then x times what is going to get me back to x. Well, I would just have to multiply x by 1 to get me back to x. So we factored GCF out of the first pair, and then for the second pair, y plus xy, we have to think what's the greatest common factor that each of them have. Well, for the first one, we just have that one factor, y. But for the second term, we have two factors. We have an x and a y, but the only one they have in common is y. So that's the only thing that we can factor out is a y. And then I can think y times what is going to get me back to y. Well, I would just have to multiply it by 1. And then y times what is going to get me back to x times y, or y times x. Well, I would have to multiply it by x. And remember, if you're not sure that it's going to get you back to the right place, you can always check by distributing, or you can kind of do it off to the side. So now we have x times x plus 1 plus y times 1 plus x. So we were supposed to look for and factor out a common binomial factor. So we have pretty much the same thing, but because these are a different order, it's kind of up to you on if you would like to rewrite it. So if you recognize that they're the same, that's fine. You can kind of move forward. If it makes a little bit more sense in your head to reorder so that they'll be exactly the same, remember that we can absolutely just switch these. So we can rewrite that second one as x plus 1 instead of 1 plus x, so that it looks exactly the same as the other one. So that's what I'm going to do in the next row. Again, it's kind of up to you as you get more comfortable with the problems. If you feel like you can forego that step, that's fine. But I'll rewrite it as x times x plus 1 times y plus x, or sorry, times plus y times x plus 1. And all we did between those two steps was switch these two terms so that what we had inside the parentheses looks exactly the same. And then now we're on step 3, where it says look for and factor out the common binomial factor. So these are common binomial factors, x plus 1 and x plus 1. They're binomials, and each term has them in common. So when I factor it out of each term, and like I said before, this is one term, and this is the other term. So when I factor that x plus 1 out of both, it comes out in front. So I'm pulling that x plus 1 out of both terms. When I pull it out of the first term, I'm left with x. And when I pull it out of the second term, I'm left with plus y. So that's what goes, or that's what stays inside the parentheses, or gets grouped back together inside the parentheses. So the second one is x plus y. So from this step to this step, we're pulling the x plus 1 out of both terms. And then when we pull them out of both terms, what we're left with is just kind of what we have left over, that x and that y. Those get grouped into their own binomial. So x plus 1 times x plus y. And then for the next two, these are for you guys to start on your own, and then we'll go through them together. Keep in mind that for B, you might want to think about how you could reorder it a little bit. And you don't have to do it perfectly the first time. If you kind of get halfway through the problem and realize maybe you should have reordered it differently, just know that you can adjust it kind of and go back to the beginning. So I'll give you guys a few minutes to work through those. Just do your best. If you're not super confident yet, start them, try them, get to where you're comfortable, and then we'll go through them together. Okay, so for A, factor each polynomial by grouping in A is a cubed plus 3a squared plus a plus 3. So remember, the first step is to kind of break it into pairs. If we look at this one, it seems like it's in pretty good order. I would say kind of like a not a rule of thumb, but one thing that you can kind of stick to is if you just have one variable, so we just have a throughout this, then standard form is probably like one of your best bets as far as the order, and this is in standard form because it goes from highest exponent down to lowest. When you have two variables, that's where it gets a little tricky because you just want to make sure that like your pairs kind of include the variables that you need them to. So I'll talk about that with B. So for A though, it's a cubed plus 3a squared plus a plus 3. So the first thing that we're going to do is break it into halves or pairs. So the first pair, a cubed plus 3a squared, and the second pair is a plus 3. So for the first pair, that's a cubed plus 3a squared. So I have to think, what's the GCF of just those two? Well, the coefficient of a cubed is just 1. So the GCF for the numbers is going to be just 1. But for the variables or the exponents, or yeah, sorry, the variables to the powers, remember that I can pull out like the smallest power of each one because that smallest power, that a squared, is automatically a factor of the a cubed, but it doesn't work the other way around. Like you could not factor an a cubed out of an a squared because there's not enough a's there. So that means that my GCF is 1a squared, but we could just write that as a squared. And then I have to think a squared times what is going to get me back to a cubed. Well, I would have to multiply in another a. And then a squared times what is going to get me back to 3a squared. I would have to multiply a squared by 3 to get back to 3a squared. And then for the second pair, it's a plus 3. So if you think like there's no GCS there, like the 3 doesn't have an A, the A doesn't have a coefficient other than 1. So if you don't see a common factor that you can pull out, and in this case, like our only possible factors would be this is like 1 times A and 1 times 3. If there's no common factor that you see, that common factor is 1. So that means that I can factor out a 1, and I would write that out in front of my parentheses. So plus 1 times A plus 3. And that's okay to just factor out a 1 because look, we still ended up with the same exact binomial in the parentheses. So we still had that common binomial within the parentheses. So from here, now I can figure out what my like common factor is or my common binomial factor is and pull it out. I want to backtrack a little bit. Keep in mind, like if you factor out a 1, that's the same thing as dividing out a 1. So that's why our binomial from like here to here did not change, because if I'm dividing out a 1, A is going to stay A and 3 is going to stay 3. Or if I think like 1 times what is going to get me back to A, 1 times A. Or 1 times what is going to get me back to 3, 1 times 3. And then from here we have our common or binomial factor for each term, keeping in mind that this is one term and then this is one term. So when I factor out that A plus 3 from both terms, that goes out in front. And then when I pull it out of the first term, I'm left with an A squared. When I pull it out of the second term, I'm left with a plus 1. So I'm left with A squared plus 1. So altogether, A plus 3 times A squared plus 1. And then for B, y squared plus 2x plus xy plus y. If I were to, you don't need to write this, but if I were to break this apart right now, just looking at those first two terms, like there's not really a common factor there other than 1. It's not really a good starting point. It might be good to kind of maybe make sure your x's are together in a pair, because there's definitely only 2 terms that have an x in it. So these 2 can be a pair, and then these 2 can be a pair, and we just need to figure out the best way to reorder them. So I think I'm just going to move this y squared to the very end. So we'll rewrite it with that y squared to the very end, and that's just going to make sure that the terms with the x's stay together and the terms with the y's. So definitely the expressions that have multiple variables, those are a little bit trickier to get used to because you have to get comfortable with setting the right order. But remember, if you don't set the right order, then you're not going to end up with the same numbers inside the parentheses. So that's kind of like, and by same numbers, I mean right here, like inside those parentheses. So if you notice that you're not getting that, you might want to go back to the beginning and reorder it. Okay, so from there we can break it apart into our pairs. So 2x times xy, or sorry, 2x plus xy, and then plus 2y plus y squared, and we can pull out the common factor from each pair. So for my first pair, 2x plus xy, the coefficient of xy is just 1. So as far as numbers go, I can only factor out a 1. And then the only common factor that each term has is this x. Since they both have an x, the first term doesn't have a y, so I can't pull out a y. So my common factor is just going to be x. And then I can think x times what is going to get me back to 2x. It would be x times 2. And then x times what is going to get me back to xy. Well, I would have to multiply in a y, because x times y would be xy. And then for the second pair, 2y plus y squared. So as far as the numbers, the coefficient of y squared is 1. So the number that I can factor out is only a 1. And then for the variables, I can pull out the lower power of y, because that y to the first power right here is automatically a factor of y squared, but y squared is not a factor of y to the first power because there's not enough y's there. So I'm going to factor out a y, or a positive y, and then that leaves me with y times what would get me back to 2y. It would be y times 2. And then y times what is going to get me back to y squared. It would be y times y. So we ended up with the same thing in the parentheses. This is the point where, like, if you didn't end up with the same thing in those 2 binomial parentheses, you would want to kind of go back and check the way you ordered it. You may have ordered it a different way than I did originally and still gotten to the right answer, which is okay. So now we have these common binomial factors. These are my 2 terms, the x times 2 plus y, and then the y times 2 plus y. So I'm going to factor out that common binomial factor from each one. So if I pull that 2 plus y out, that comes out in front. When I pull it out of the first term, I'm left with x. When I pull it out of the second term, I'm left with y. So in my second parentheses would be x plus y. So if you ordered it a little bit different than me initially, the order of your final answer might be a little bit different. For your final answer, if say these whole like both parentheses were flipped, that would be fine. Also, it's okay if the terms inside the parentheses were flipped. So if you ended up with like a y plus 2 and say like an x plus, or sorry, a y plus x, that's technically the same problem because you're allowed to switch the terms like that and you can switch factors. So keep that in mind.